When most people think of nuclear power plants, they imagine enormous cooling towers, massive concrete domes, endless pipes, and gigantic complexes that dominate the landscape. Projects that take decades to build, cost billions of dollars, and spark both admiration and fear. That has been the traditional image of nuclear power for half a century. But today, a new idea is gaining momentum: small modular reactors known as SMRs. These reactors promise to change how we think about nuclear energy, offering a solution to some of the biggest challenges of the 21st century: the growing demand for electricity, the urgent need to cut carbon emissions, and the necessity of reliable, stable energy sources. Why small reactors? The problems with traditional gigawatt-scale plants are well known. They are huge, complex, and notoriously slow to build. Delays of 5 or 10 years are common, and every delay adds billions to the price tag. Politically, they are risky investments because they outlast several election cycles. Even though nuclear power offers carbon-free, round-the-clock electricity, many governments hesitate to commit to massive projects that will not come online for 15 years or more. SMRs aim to change this equation. The idea is simple but powerful. Instead of building a single enormous block that produces over 1,000 megawatts, you build several smaller units, each producing tens or hundreds of megawatts. These modules can be manufactured in factories, shipped by truck, rail, or barge, and assembled on site like building blocks. This is a revolution compared to the bespoke, one-off construction of traditional nuclear plants. By moving much of the work into controlled factory conditions, costs and quality become more predictable, construction times shrink dramatically, and projects become far less risky. Imagine a mid-sized industrial town that needs steady electricity and heat. Today it might rely on coal, gas, or expensive imported fuels. In the future, it could simply install 1 or 2 SMR modules that provide clean power and district heating for decades. SMRs could be deployed in places where large nuclear plants would never make sense: remote northern communities, islands, mining regions, or alongside large factories and chemical plants. Safety is another key advantage. Modern SMR designs use passive safety systems. That means if something goes wrong, the reactor shuts down and cools itself without the need for pumps, human intervention, or complicated electronics. They rely on the laws of physics: gravity, natural circulation, and heat conduction. This dramatically reduces the risk of an accident on the scale of Chernobyl or Fukushima. And because each SMR contains far less fuel and a smaller energy inventory in its core, even in a worst-case scenario, the consequences are much more limited. The SMR family is diverse. The most straightforward designs are scaled-down versions of the familiar pressurized water reactors. These are closest to commercialization because regulators are already comfortable with the underlying technology. But there are also more advanced concepts: reactors cooled by molten salt, helium gas, or liquid metals like sodium. These promise higher efficiency, the ability to use different fuels, and even the potential to burn existing nuclear waste. Most of these, however, are still in the development or demonstration phase. So who is leading the race? In the United States, the company NuScale has developed a 77-megawatt module. Their design has already been certified by the Nuclear Regulatory Commission, a major milestone. The first plant, combining several modules for over 400 megawatts of power, is planned in Idaho. Canada is pushing SMRs to power remote mining operations in northern communities, replacing costly and dirty diesel generators. Russia already operates the Akademik Lomonosov, a floating nuclear power station that supplies electricity and heat to a city in Siberia. China is testing its own designs, including a molten salt reactor. Europe is also getting serious. Poland has signed deals with GE, Hitachi, and NuScale to deploy SMRs as replacements for coal plants and tow-power heavy industry. The Czech Republic is considering SMRs at Dukovany alongside new large reactors. The United Kingdom is supporting the Rolls-Royce SMR project, leveraging aerospace expertise to create a national nuclear industry. The potential uses go far beyond electricity. SMRs can provide district heating for cities, industrial steam for chemical plants, and even produce hydrogen for future fuels. In this way, they could become a key tool for decarbonizing not just power generation, but also industry and transport. But SMRs are not magic. Critics point out that per megawatt costs are currently higher than large reactors. The business case depends on mass production bringing prices down. The waste problem does not disappear either. Smaller reactors still produce spent fuel, even if in smaller amounts. And licensing remains a major hurdle. Every country has its own nuclear regulations, and adapting them to new designs takes years. The market is crowded as well. Dozens of companies and nations are pursuing their own SMR designs. Realistically, only a handful will survive and become global standards, while others will fade away. This is normal in new industries. Think of the early days of automobiles or computers. Despite the challenges, the potential is enormous. SMRs could replace retiring coal plants using existing infrastructure, supply clean energy to isolated communities, and provide stability to renewable heavy grids. Even smaller microreactors, producing just a few megawatts, could be trucked into remote sites, military bases, or disaster areas to provide power where no grid exists. Public perception is another crucial factor. Gigantic nuclear plants can seem intimidating and remote. Smaller reactors, designed with passive safety and limited energy inventory, may be easier for communities to accept. They could be placed closer to where people actually live and work, serving as local, reliable energy sources. Geopolitics also plays a role. Exporting nuclear technology means securing long-term influence. Selling an SMR is not just a one-time deal. It creates decades of relationships through fuel supply, maintenance, training, and oversight. That is why the United States, Russia, China, Canada, and Europe are all investing heavily in SMRs. Whoever dominates this market will gain not only economic benefits, but also strategic leverage. Looking to the future, there are two scenarios. In the optimistic one, by the 2030, dozens of SMRs are operating around the world, costs are coming down, and the technology has gone mainstream, just like gas turbines today. In the pessimistic one, early projects prove too expensive, public opinion turns sour, and SMRs remain a niche. But given the urgency of decarbonization and the global hunger for clean, firm power, SMRs have a real chance to succeed. It may turn out that the age of huge nuclear plants was just the first chapter. The second chapter could be written by small modular reactors, powering towns, industries, and hydrogen plants across the world. How fast this happens will shape not only the future of energy, but the future of our planet.